Welcome everyone. In this video, we will discuss command and amplifier, that is basically our source follower, and common corrected configuration, that is our emitter follower, and how to find their AC equivalent model. Okay, how to draw the AC equivalent model, their voltage gain, and the output impedance calculation. So why I have taken both BJT one and MOSFET one, because sometimes it is very important that we have to go for the actual expression for the voltage gain and impedance. So through this presentation we will cover how to develop the AC signal analysis for the common drain and common collector configuration. That is our, this one is our BJT one, this one is our BJT. Okay, and this one is our MOSFET, MOSFET one. Okay, so so and the property of this circuit is that here the source follower means the source follows the input, output, or we can simply say the output follows the input, input with same phase, with same phase. Okay, means in this case also the output follows the input also. Here I am also writing output follow the input with same phase, with same phase, and both are used as a buffer. Okay, and both are used as a buffer with high input impedance and low output impedance, both having high input impedance, both having common features like buffer, high input impedance, low output impedance. Now we will discuss the gain, how to find out the gain, voltage gain and impedance. Okay, so basically this one is our, first I am going for this one. Okay, source follower. Okay, source is common, drain is, sorry, so we are taking output across the source and drain is common. Okay, so in case of source follower, in case of source follower, what we will do, this should be, for the AC equivalent it should be grounded. Okay, in this case also this should be grounded when we go for the AC equivalent model, for the AC equivalent model of source follower. And here I am writing AC equivalent model of emitter follower. Okay, means what we will do, parallelly we will see means how to draw the AC equivalent model for this one. Okay, here the, here this one is the transistor. Okay, MOSFET, and here this one is our BJT. Okay, here you can take it green. Okay, so now we have to draw the AC equivalent model. So supply we have to make it ground. So here what we can say, VDD we have to make it ground. Okay, and here we are saying the VCC we have to make it ground. Capacitor C1 C2 sorted. Okay, here also C1 C2 sorted. Okay, so what I am doing, directly drawing the AC equivalent model for this MOSFET. So this MOSFET equivalent model is somehow, this is our plus minus VGS, This was a very fundamental thing. Okay, so basically this one is our VGS and this should be our GMVGS for this transistor. Okay, and this one is our, what we can say, this one is our source resistance. So we are making one resistance here, that is our RS. Okay, and if this transistor have some finite resistance, say R naught, so that R naught will come here, R naught. Okay, and this should be grounded. I have already made a video on this source follower and emitter follower. I will share the link for both design, and here I'm just doing a comparison kind of thing, means how to develop, means for the transistor we have VGS, GMVGS, and this should be our what, our RS, RS, and we are taking output from this side, that is our V0, and this one is R1 R2. So both R1 R2 will be in the pattern. Okay, this one is R1 R2, and we can say this one is simply our V in, this one is V output, R output, and this one is our RS. Okay, RS, and this should be grounded. Okay, so basically this portion is our this. Okay, I am just transistor. Okay, and this GMVGS, everything is okay. Now RS is in, just because this side is our what, gate, drain, and this point we can say source. Okay, so this one is simple representation. Now this one is grounded. Okay, for AC analysis, so R1 R2 will be in the parallel and capacitor sorted, so V in will be there. Okay, similarly R0 is the output, finite output resistance. We can do without R0 also, but we have to take the R0. So R0, so RS V0. So this one is the representation for the S equivalent model. Okay, now we have to do it for the BJT. So BJT, again, what we will do? We know the S equivalent model, how to draw. Okay, there will be a resistance, there will be some current source. Okay, and there will be some finite resistance. In case of BJT also I am taking. So we will put here, and this will be grounded, and RB. Here only will be the RB resistance and capacitor sorted. So I'm just writing. This should be our V in, this one is RB, this one will be R pi, and this voltage will be V pi, and this one is our GM V pi, R naught, okay, and one resistance, R is resistance here. Okay, I have already made a separate video on both emitter follower and source follower. So here I am just for R E, and this should be our V naught, okay, and here we can say this terminal is our base, this we can say the collector side, emitter side, okay, and this one is nothing but some okay, very simple representation. Clear, we have to very careful. If you, for this transistor you have to make like this, and not everything. So now we have to move ahead for the voltage gain. Okay, so I'm just going for this diagram. Okay, parallelly we will do one by one. Okay, so now we can say this one is the S equivalent model of these two. Okay, so now for the voltage gain, so now what we will do, here we can say this current is our is source current, gate current is almost zero, so no need, and this will be I of D. Okay, and this current I am saying this current, some current will flow like in this one, like I R naught. Okay, so by applying KCL at point S, I am writing here, by applying KCL at point S. Okay, I will solve first this one, then after that, otherwise you will confuse if you do parallelly. For up to this it is okay, so but now I will finish this portion first for the common source amplifier. So the current, that is our, say, this side, this one is RS. Okay, some current is going like this, IS. Okay, and this point is our, sorry, S. Okay, and some current is going like this, that is our I R naught through a resistor. Then after we have to give a current source like this. Okay, that is our GM VGS. Okay, so now this one is our R naught, and this one is grounded, somehow grounded, zero potential. Okay, so we have to apply Kirchhoff's current law. So for the Kirchhoff's current law, total incoming current at this point, incoming current, so incoming current is IS, sorry, total incoming current equals to total outgoing. So outgoing will be like IS plus I R naught equals to incoming one GM VGS. Now IS we can say, because this potential is plus of minus V naught, so this potential will be V naught. So IS can be written as V naught by RS, and this voltage V naught by R naught. Simple. Means what I am doing, if some resistance is there, say R1 is there, and this one is V naught potential, or say this one is simply a RS, so this IS will be V naught minus 0 by RS, so V naught by RS. So this current will be V naught by RS. So this should be V naught by RS. So V naught equals to 1 by RS plus 1 by equals to GM VGS. So the V naught value we can write as R naught plus R naught into RS GM VGS. Okay, so this can be also written as V naught equals to GM VGS into R naught into RS by R naught plus RS. Okay, so this should be our GM VGS, and this can be written as R naught parallel with RS. So I'm like writing like this. Because this term is nothing but simply R naught parallel with RS. Okay. So V naught is nothing but simply okay. Line. Is it clear? This point up to this point, is it clear? Means V naught is now our GM VGS R naught parallel with RS. So this one is the V naught value. Now we have to make a relationship between V in. Okay. So for this purpose, what we will do, we will write a KVL equation in this loop. For this purpose, we are writing a KVL equation in this loop. Okay, say loop 1. If we apply KVL in this loop, what we can write V in minus VGS minus V naught, because this one is our V naught. So one can write simply KVL in that loop 1. KVL in loop 1. So one can write simply V in minus VGS minus V naught equals to 0. So V naught equals to V in minus VGS. Okay, is it clear this point? Because if this one, this potential say V in, then minus VGS minus V naught plus minus V naught, so minus equals to 0. So the same equation I have written here. Then after, what we can do, V naught is there, V in there, and VGS. So we can replace the value of VGS, V naught equals to V in, we can write it V naught GM R naught parallel with RS. Okay. So then after, what we can write, this V naught will be 1 plus 1 by GM R naught parallel with RS, okay, equals to V in. Simple calculation. Then after, finally what we can write, V naught by V in equals to 1 by 1 plus 1 GM R naught parallel with RS, or simply GM R naught parallel with RS, GM R naught parallel with RS plus 1. Okay, clear this one? So now this one is the gain calculation. So this one is the gain calculation. V naught by V in. Okay, V naught by V in, that is our AB equals to, one can also write like this, R naught parallel with RS 1 by GM. If you take GM both side, then R naught parallel with RS. Anything you can write, or simply our GM R naught RS GM R naught parallel with plus 1. So this one is the expression for the gain. Okay. So now for one, for easy representation, now one I can make a circuit for this one. If I am saying this one is our V in, and we are taking output as this, and so this should be our 1 by GM, and it should be R naught parallel with RS. So V naught, if we divide voltage divider, it V in R naught parallel with RS divided by 1 by GM plus R naught parallel with RS. This one is the output gain, and if we have to find the input impedance, that is our Z naught, we have to keep it V in 0. Okay, we have to make it ground. So if we have to make it ground, it should be 1 by Gm parallel with R0 with Rs. So this one is the very important observation we can find by keeping this V in grounded. Okay, so 1 by Gm and this should be parallel. Okay, so this should be the output impedance. So like this we can find the gain and output impedance. When there is no R0, so one can simply write Rs V in Rs by 1 by Gm plus Rs. Okay, with Rs, without Rs we can write. Now we will do for the this one. Okay, now for this one again what we will do, we have to apply KCL at point E, just similar to S. Here we S, so here what we can say, this one will be IE, this should be IB, some current like this one is IC, and some current IR not I am making. Okay, what it shows that through this RE some current is flowing. Okay, then after some current in this one. Okay, and some current is going coming here, and one more current. Okay, that is our R pi. Okay, and this voltage is V pi. Okay, so what we can say, this one is IB, IC, GM V pi, and this should be our, this voltage is our V naught voltage, and this is grounded. Okay, so if we apply KCL at point E, IE, so IE, the total outgoing current is I, and this current we can say as I R naught, I plus I R naught. Okay, outgoing, and I, and incoming IB plus GM V pi. Okay, now the current IE, I current V naught by RE. This should be V naught by R naught. Very similar to this one. Okay, see, and IB is there, so IB will be V pi by R pi plus GM V pi. Okay, now if we take common this one, 1 by RE plus 1 by R naught, and if we take common V pi, 1 by R pi. Now I am putting this R pi equals to 0, because 1 by R pi is somehow 1 by beta by Gm. So Gm by beta. So this Gm by beta is much smaller than Gm. So that's why we are neglecting this one. Okay. So this one can be written as V naught, then R naught plus RE into V pi Gm. Okay. So the V naught equals to written as V pi Gm into, in bracket we can write RE into R naught divided by RE plus R naught, and we can write it V pi Gm RE parallel with R naught. This is very simple. Okay, means in addition to this one we are writing this. So overall V naught we have find V naught equals to V pi Gm RE parallel to R naught. Very similar to this one. Gm V pi RE parallel with R naught. Okay. So next we have to go for the KVL in this loop. Okay, I'm selecting pencil. Now applying KVL in loop 1. Okay. So what we write, KVL in loop 1, just very similar to the earlier one. It will also give V in minus V pi minus V naught equals to 0. So V naught equals to V in minus V pi. Okay, very simple. V naught equals to V in minus V pi. Okay, now from here we can put the value of V pi. From this one we can put the value of V pi as V naught by Gm Rd parallel to R naught. From this, okay, we have also put at this value, means Gm value, okay, VGS value like V naught by Gm, okay, from this equation. So what we can do, V naught 1 plus 1 Gm Re parallel with R naught, or we can write R naught parallel with Re, okay. So if we solve in a very similar manner, we will get V naught by V in will be Gm Re parallel with R naught by Gm Re parallel with R naught plus 1. Okay, very similar manner. If we do like this, it will come. Okay, or we can write it Re parallel with R naught 1 by Gm plus Re parallel with R naught. Okay, very similar expression as that of the common source or source follower. Okay, these two are very similar kind of thing. Okay, so that's why I have made this video, means how both are almost same kind of. Okay, so what we can do now, finally what we will do, means it should be our 1 by Gm, it should be V in, it should be V out, so this value will be Re parallel with R naught. So this one is nothing but simply this expression, V out, V out equals to V in into Re parallel with R naught by 1 by Gm plus Re parallel with R naught. Okay, for output impedance, very simply, for output impedance, what we have to do, we have to make it, this should be grounded, and we have to take this one as a Z naught. So Z naught will be Re parallel with R naught parallel with 1 by Gm. So this one is the expression for the output impedance. Okay, so both are very similar, but how we have to do, this is the method. So if we are doing without R naught, okay, Z naught will be simply Re parallel with 1 by Gm. So I have already made a separate video on this topic. I will share the link. So this is all about the comparative analysis, how to solve and how both are very similar. Okay, means everything is similar, Gm R naught, but here Re, here Rs. Okay, and everything is same. So this is all about this lecture. So I hope you like this video. So thank you for watching this video. Thank you.